Hello, I'm Jenny Lynch, and this is the Creative Science Podcast.
Hi, I'm Matilda, and today's show is all about artificial intelligence.
We will explore the different types of artificial intelligence, take a deep dive into self-driving cars, find out if AI robots are taking over the world, and play noughts and crosses against an algorithm that will beat you every time. Switch on your real human brain because here come 5 fun and fascinating fast facts about artificial intelligence, or AI for short.
Fact number 1. Artificial intelligence is about using computers to do things that humans can do.
AI can be used to do things that usually require a human brain. Things like recognizing pictures, looking for patterns, and finding solutions to complicated problems. But unlike us humans, computers can work super fast, and computers don't need to sleep, or eat, or take a toilet break.
Fact number 2. Computers are very good at following step-by-step instructions.
An electronic calculator is a computer that can follow instructions to add, subtract, multiply, and divide numbers. The difference with artificial intelligence is that not only can it follow instructions, but it can also learn from its mistakes and come up with a new set of instructions to follow. AI can learn and get better at things.
Fact number 3. Artificial intelligence algorithms can learn by looking at lots and lots of information that would take far too long for humans to look at.
Humans have been collecting information about the weather every day for a very long time. An AI algorithm can scan through all of that data and look for patterns that could help to predict the weather in the future.
Fact number 4. The huge amounts of information used to train artificial intelligence algorithms is called big data.
As computer storage gets bigger and computers get faster and faster, more and more data is being used by AI algorithms.
Fact number 5. Computers store information as ones and zeros.
For example, when you type your name into a computer, each letter in your name is stored as a series of ones and zeros. Each one or zero is called a bit, and the order of the ones and zeros is a code for the letter. My name is Jenny, so the first letter of my name is a capital J, and it would be stored in a computer as the following 8 bits. 10101010. Each letter of my name uses 8 bits of data, so all 5 letters would be 40 bits. Now, imagine if everyone in the world had their names written as ones and zeros, and all of the books in the world were turned into ones and zeros. All the pictures and videos you see on the internet are saved on computers as ones and zeros, and they take up a lot more ones and zeros than the letters of the alphabet.
Now that's what I call big data. You've probably already come across artificial intelligence, even if you don't know it. Here are a few examples.
When you do an internet search, AI algorithms try to find the websites that best match your search. They might even remember what you searched for in the past and use that information to make more suggestions. YouTube uses AI to make recommendations about what videos you might like to watch, based on what you might have watched in the past. Digital assistants like Siri, Alexa, or Google Assistant all use AI to answer questions. GPS navigation systems like Google Maps use AI to work out the shortest or the quickest way to get to your destination. AI is also behind facial recognition technology that's used to unlock smartphones or to match the faces of people in photos with their names on social media.
Let's take a deep dive into how artificial intelligence is used in self-driving cars.
There are enormous self-driving trucks working in mines to move around huge amounts of iron ore. Autonomous trucks need sensors so they can detect the road and any obstacles in the way, and they use GPS or global positioning systems to guide them in the right direction. Self-driving cars aren't allowed on public roads in Australia yet, but one day you might be cruising around in a car with no driver. While the sensors and GPS in a self-driving car might be able to keep the car safely on the road, what if something unexpected happens, like a tree falls across the road or a small child chases a ball onto the street? Self-driving cars need artificial intelligence to process all the information coming from the sensors and make decisions about what to do in an emergency. If a tree falls across the road, the artificial intelligence can sense the obstacle and decide to stop the car as quickly as possible. But what if a child runs onto the road and the car can't be stopped in time? What if the only way to avoid hitting the child is to drive the car into a brick wall? How will the artificial intelligence decide between hurting the child or hurting the people inside the car? Scientists and engineers are still working on improving self-driving cars to make them safer and to train the artificial intelligence algorithms driving the cars to make the best possible decisions. At the moment, human error is the cause of most car accidents. When a human makes a mistake while driving a car, the consequences can be very serious. If AI can drive more safely without making any human errors, the roads in the future could be a lot safer.
Now it's time for a question. Will AI robots one day take over the world?
Some people worry that it might be dangerous to make machines too intelligent. Being human isn't just about intelligence. It's also about caring for other people. And some researchers think there should be more rules to make sure AI can only be used safely. For example, it might seem like a great idea for AI to recommend the best websites or YouTube videos for you to watch. But what if that means AI is constantly collecting information about you? It could find out all your likes and dislikes, where you live, the names of your friends and family, and even the details of your facial features. There are a lot of concerns that businesses are using too much of this information to target advertising at people in order to sell more products. And what about facial recognition? What if someone called Bob robbed a bank, but Bob happened to look a lot like Steve? What if facial recognition technology made a mistake and Steve went to prison for a crime he didn't commit? Mistakes like this happen in human systems, but we need to make sure AI is designed to avoid making errors that could have serious consequences for people. There is a lot of new technology that uses generative AI. This is artificial intelligence that can create artworks and even write books. The problem is that the AI learns how to create these things by scanning through existing artworks and written text. Artists and writers are concerned because their original works are being copied and repackaged by AI. Generative AI also makes a lot of mistakes. If you type a question into an AI chatbot, it might give you a very confident answer based on the data it has scanned, but it won't necessarily be the correct answer. The answer will only be correct if the data it scanned was accurate information and if the algorithm was designed to learn from the data in the best possible way. There are exciting times ahead in the world of artificial intelligence, but there is also still a lot to learn about how to make sure it is safe and beneficial to society.
The human brain is very good at doing lots of different things, including finding patterns, recognizing images, understanding language, and being sensitive to the feelings of other people.
While some AI systems can recognize images or even write text, each AI system is usually only really good at one thing. Humans are good at doing lots of different things. Sometimes we do lots of different things all at the same time. Think about playing soccer with a team, blowing a trumpet while reading music, or driving a car on a busy road. Human brains are also good at transferring skills from one situation to another. If you know what a cat looks like, and you see an animal that is similar to a cat, you will assume that it falls into the category cats. Get it? Category? Or let's say you see a cat in an unusual situation, like a cat playing a piano, you will still recognize the animal as being a cat. If an AI system has been trained to recognize images of cats, but it comes across an unusual looking cat, it might put the image in a different category. Also, an AI algorithm that is designed to recognize images of cats will not be able to also drive a car or tell you if it's going to rain today. For many years, researchers have talked about general artificial intelligence. This is the idea of an AI system that works more like a human brain. It's AI that can do lots of different things, and this type of AI system could potentially become more intelligent than a human brain. For now, though, most AI researchers think this type of system may never be possible, or at least it's not possible with current AI technology.
An algorithm is a set of instructions. For example, a recipe or an instruction book are both algorithms. How would you like to play a game against an algorithm? You will need a piece of paper and a pencil.
Start by drawing a grid to play noughts and crosses. You will play normally, but you will be playing against an algorithm. I'll read out the moves from the algorithm, and the algorithm will win or draw every time. If it doesn't sound much fun for you to lose or draw every time, keep this in mind. You can learn the algorithm yourself and use it to win or draw every time you play noughts and crosses against someone else. You might like to pause the podcast while you find the paper and pencil and draw the noughts and crosses grid. And you can also pause at any time while we play the game. Are you ready? Okay, I'll be using the algorithm and you'll have to draw my moves in the grid. The algorithm has the first move and is playing the game as crosses. You'll be playing the game as noughts, and the object of the game is to get 3 noughts in a row or 3 crosses in a row. And the row can go up and down, side to side, or it can be diagonal. Okay, I'll have my turn first. Draw a cross in one of the corners for me. Now it's your turn, and you can draw a nought wherever you like. For my next turn, I need you to draw a cross in the opposite corner to the first cross, if that corner is available. If that corner is not available, then draw a cross in one of the other corners. Now it's your turn again. Where will you draw your nought this time? It's my turn now. This turn is a little bit more complicated. If there are 2 crosses in a line with a space, draw a cross in that space. Otherwise, if there are 2 noughts in a line with a space, draw a cross in that space. Otherwise, draw a cross in a free corner. It's your turn again, so you need to decide where to draw your next nought. My next move is similar to the last one. If there are 2 crosses in a line with a space, draw a cross in that space. Otherwise, if there are 2 noughts in a line with a space, draw a cross in that space. Otherwise, draw a cross in a free corner. Is the game over yet? If not, you have your turn and draw another nought. Is the game over now? If not, draw a cross in the last free space to end the game. Did the algorithm win or draw? Try playing this with a friend and see if you can win or draw every time using the algorithm. A computer could be given this algorithm by writing it as a computer program, and the computer would win or draw the game every time. Do you think that's artificial intelligence? Or would artificial intelligence need something a bit more complicated than simply following a set list of instructions? Artificial intelligence is becoming a lot more complicated than this type of simple algorithm. What if the computer was shown the game of noughts and crosses without knowing any of the rules? Using machine learning, the computer would learn the rules by playing the game. If it lost a game, it would learn to try a different move next time. By playing the game over and over again, the computer would learn how to win. It's a little bit like a human learning something new. We sometimes learn by trial and error, and we learn from our mistakes. My real human intelligence tells me it's time for us to go. Thanks for listening, and remember to stay curious.
The Creative Science Podcast was recorded on the traditional lands of the Bidjigal people. For more information about Creative Science Australia, visit creativescience.com.au.